Okay. Since people will be, checking this recording, I will take this in English. But புரியலைன்னா சொல்லுங்க. I will take it in Tamil as well. Fine. So in this class, we are going to look at these topics. I don't think I can cover all these topics by today, but I will try to cover as much as I can. Okay. So we are going to talk about asynchronous versus synchronous programming, callbacks, promises, fetch API, async await. I know these terms are new to you, but we will go through all the basics, and you can, like I always say, please stop me if you have any doubts, and I will explain you then and there. Okay, awesome. Now, JavaScript is a single-threaded programming language. Okay, so why do we say that? So what is the problem with single-threaded programming when it is a single-threaded programming language? Anyone? Okay, I will continue. Maybe stop me if you have any doubts. Okay, so let's say you have a long-running program or while loop. That while loop has like millions of items. Now inside the while loop, you are doing some operations. Let's say you are console logging or something. You are doing something. Something like while loop or for loop. So let's say in this case, we are doing array.length. Instead, we are looping through like very large number. So this will take a lot of time, right? Until this operation happens, when browser is handling this particular operation, it cannot handle any other operation because, like I said, JavaScript is a single-threaded programming language. So what happens when user try to move her mouse or she tries to click it? Okay, she cannot do that because JavaScript is busy running this program. It cannot handle other events, anything other than this particular program, like mouse click, mouse move, or scroll, or anything. So the whole program is blocked by this particular piece of code. Okay, that is the problem with single-threaded programming language. Okay, so now this is where the asynchronous and synchronous part comes in. So basically, JavaScript is synchronous in nature. Like it executes the code line by line. So it comes to line 6, it will start importing these things. It will come to this line, document.query selector. It will try to select this thing, then run this for loop, then come here. Okay. So now, where does this asynchronous part comes in? So to understand this asynchronous part in JavaScript, you need to understand the event loop in JavaScript. So how JavaScript handles this event loop, and even being a single-threaded programming language, how JavaScript manages to execute faster and handle a lot of operations. Okay, so there are 3 components in this. One is call stack, callback queue, and the web APIs. Okay, so let's say the call stack is nothing but you have a list of functions. In this case, you have a console log, you have a logger, you have a main, and there may be a function to add, subtract, or something like that. So list of functions that need to be called. Okay, your function execution is in synchronous order, right? So all these functions will be added in the call stack. You know what is a stack? Okay, first in, last out, right? So same stack data structure here. The functions will be added and it will be executed one by one. The lastly added function will be executed first, something like that, right? Now, what this event loop does is like, its job is to execute, look at what is happening inside this call stack, between this call stack, callback queue, and web APIs. Give me a second. Sorry, someone came. Okay, now, like I said, we have call stack, this callback queue and the web API. So what is this web API? So this is where the asynchronous part comes in. So when it comes to operations that might take time, you might want to run it in a separate place, and then once that is completed, you just want to inform, you just want a mechanism that informs the single thread. We call it as main thread. In JavaScript, we call the single thread as, when we say single thread, it's the main thread. Okay, so this main thread runs all the program, like your for loop and all these, the call stack part, handling the call stack part, callback queue and everything. Okay, now, but what happens is it doesn't run the set timeout or some DOM events and any external API calls. Let's say you're making external API calls to fetch a list of items like to-dos, or let's say you are working on a movie booking application. You need to hit the backend, get the list of movies and all those stuff, right? So all those things are handled by API calls, like we discussed in some of the previous introductions. Okay, so all these things will be handled separately from the main thread. So this web APIs are part of browser, which take care of running all these stuff. Okay, the browser will take care of separately run these things. So ideally, what you need to remember is this web APIs will be run by the browser, not the main thread. Okay, this main thread just says this event loop, like I have a particular set timeout, I have a particular API call that I want to execute, and then it continue working on this call stack. So I'll talk about the callback queue now. Now let's say you have delegated this work to web APIs. Now this work has been completed. So this completed work need to be communicated to the main thread so that it will add that to the call stack again, and this cycle will continue. So let's say you are making a API call. Okay. Now the event loop system, you tell the event loop system, I want to make a API call. Now this web APIs part will kick in, and then it will make the API call. And then at the same time, it won't block the main thread. The API call will be running in a separate thread. Okay, browser will take care of running it. But when the API call finishes and gives the data back, this callback, it will be added to this callback queue. Okay, so this callback queue will then added to the call stack. Then the call stack will execute it. So this is a very important concept. If you have any doubts in this, ask me. Any doubts? Akash?
No, sir.
So we will see this in a very simple example. I will remove all these things. I will try to run this code. Let's try to console log hello, just to see if everything's working fine. We will run this. We see nothing but the hello. Okay, everything's working fine. Now we will add few things here. So let's say I will add a variable name equal to John Doe, and I will do a set timeout. So set timeout is a web API. Okay, so this will be delegated to, this will be taken care by the browser, since it's part of the web API. This will be still run by the main thread, which is our single thread. Okay, now Set timeout is something like saying like, I want to execute this after 2 seconds. This is in milliseconds. So let's say I'm changing the name here as Jendo. Okay. Now, let's see, I am console.logging the name here. Okay. So we call it name outside set timeout. We call this name inside set timeout. Okay. Now we go back to the browser. We refresh this. So what you can see here, first hello has been executed, then name outside the set timeout has executed. See, ideally the program flows like this, right? You have a console log hello, then you are defining a variable called name, and then you are calling the set timeout. Inside the set timeout, you are doing Jendo, and then you are printing the name after changing it. Okay, then you are console logging it outside. So ideally, John Doe name has been changed Jane Doe. Here it should print Jane Doe. Again, here it should print Jane Doe since it has changed the name. But the order is hello, which is right. Name outside the set timeout. Immediately it jumped here and then it jumped back inside. Can anyone explain why? Based on whatever I have told, try to explain this so that I can infer you have understood it correctly. Anyone? Akash?
Yeah, so since we have given a set time as 2 seconds,
Mhm.
so in that meantime, it will automatically executes that set time as John Doe. Then only it will go there. If we have mentioned it as 500,
Mm, mm,
it will have
mm.
actually executed it in order wise actually.
Seriously. So I will still give a discount for you. I will execute in 100 ms, not 10 ms. I will execute. What do you think now? It will print this first, right? Based
Yeah,
on
yes,
you.
sir.
Okay, let's try this. Oh, same. Which means, so I still this concept is confusing for you, I believe. Right? Give me a second. Someone else is joining. Hey, Amulya. You are a little bit late. I'm explaining the concept of asynchronous and synchronous programming, why JavaScript is single thread, about the call stack, callback queue, and web APIs. But between, if you have any doubts, you can ask me. Can you hear me, Amulya?
Yes, sir.
Okay, awesome. Okay, so now, so we have this program which does a console log hello, declares a name, have a set timeout, and another console log below that. Now the order of the program is something like you define a variable here, you are changing the name, and then you are printing it here. So ideally, you should think like John Doe, and here it will print name inside John Doe, then it will print name outside John Doe since it has changed. I'm just repeating everything since Amulya has joined now. But yeah, this is totally different. Name outside set timeout has logged, which is totally unexpected. Okay. Now I will explain why is this case. Like, thanks Akash for anyways trying this out. Now we talked about web APIs. So you can see set timeout is part of web API. So what happens when the JavaScript compiler, which means the browser is running your JavaScript in this case, right? When browser's JavaScript engine encounters this set timeout. So it will be, like I said, the web APIs will be run by the browser, not in the main thread. Not the main thread. The main thread won't run the web APIs, but the browsers will take care of running it. And one more thing, the browser internally runs web APIs in a separate thread. Okay, not in the main thread. So the main, since it is a single threaded programming language, it will keep on executing it. It will come down, keep on executing. Encounters a web API here. It will tell the browser, run this for me. Let me know when this has completed. So the main thread will tell browser, run this for me. I'm writing this because this is a very important thing. But let me know when you are done. Okay. So now what happens is like the browser will run this set timeout. And once this timeout has been completed, in this case, 10 ms. Okay. Even if it is 0 ms, it will delegate it to the main thread, immediately go to the next line. Okay. So that is what we call as next tick in JavaScript. So remember this, there is something called next tick. Whenever it encounters the main thread, even if it is 0 ms, I'll change this to 0 now and try to run this program again. There is no change. Still outside set time mode is executed, inside set time mode is executed after this. Because again and again, I'm repeating again here, like whenever the main thread encounters a web API, it will delegate it to the browser, and it will be run in a separate thread. And after it completes, the browser will let the main thread know I have completed this. Now add it to your call stack. So what is a call stack? It is a list of functions the browser has to run. Now, once this particular set time is completed, it will be added to the callback queue first, which means there will be more web APIs. Everything will be keep on completing, right? So there will be a callback queue. So queue is first in, first out. Okay. So let's say I have 3 set timeouts. So for each set timeout, a callback will be added here in the callback queue, and based on the queue, it will be added to the call stack, and the browser keep on executing it, and the same cycle keeps on continues. Any doubt in this? Arvind, Godwin, Amulya, Jayadashni, Pavan.
No, sir.
No,
sir.
What is confusing here? Like any part
No.
is confusing here?
No, sir.
You're clear, right? So now let's say browser don't have this system. This system seems confusing. Why are we having this complex system? What happens? Based on our discussion, what happens if we don't have this call stack or callback queue, this whole event loop system? Can anyone tell me what happens if it doesn't exist? What happens? Come on, folks. We will move to the next
It will
step.
take more time. It will take more time to execute.
So at that particular time, the main thread will be what? Busy doing that.
And that is
Task.
asynchronous.
Correct.
Yes, sir.
So the main thread will be busy doing that one single task. So let's say this set timeout is for 1 hour. 1 hour, you can't even move your mouse. Is that fine? So now what happens with the web API? So it will delegate it to the browser. Browser will take care of telling the main thread that 1 hour has been finished. So here is the callback executed. So I'm saying callback. Can anyone tell me what is this callback? Based on the name. So we have a set timeout here, and there is this function. We call it anonymous function. It doesn't have a name. Arrow function, anonymous function, whatever you call it. Even you can add a normal function here, like you can do something like this. This will also work. So this is what we call it as a callback. So based on this name, after this particular time completes, so in this case, like let's say 5 seconds, call this function. Okay, but what if I have multiple functions like this? Okay, the web API will take care of running all these set timeouts and then add it to the callback queue. The first set timeouts callback, which is this one, will be added first, and then this one will be added second, and then all these things are added to the call stack, and the browser will start executing each function one by one. So this is how it happens. So in this way, the whole main thread won't be blocked, right? So unless and otherwise, you are explicitly running a for loop like this, like initialize, right? Let's say you are running a for loop for some 1 million items or something. Now the main thread cannot do anything. Or explicitly blocking the main thread here, and this is not a browser API as well. For loop is not a browser API as well. The browser will execute this whole for loop, and then only it can do anything else. Okay. Okay. So you know what is a callback now. So I will give you some other examples for callback as well. Let's say you have a button. We call it click, and we have let's give us ID and call us BTN. Okay. Now I want to target this button. So we call it const btn equal to document dot get element by ID btn. We got the button instant. What we can do is like button dot add event listener. What event are we going to add? We are going to add a click event. Now, once this button is clicked, I want to do something. So how can I do something? I can do it via a function. So we call a function here, and this function will be given with the event parameter. What type of event it is? We will console log this event for now. We will do alert and say button click, and then we will do a console.log of the event. Okay, we go back to the browser, refresh this. We got the button. I click it. We got the alert. So one thing you can note here is like once I click the alert, till I say okay, I can't do anything else. So this is something you can relate it with what happens if main thread is blocked. Okay, you can't do anything, something like that. Okay, now it has given me the event. So this event object will tell you like what is the clicked element and all the other properties of the clicked element. In this case, the clicked element is a butter. Where it is in x-axis it is in 14, y-axis it is in 24. All those stuff, all the properties of the button will be there in the click event. You can do whatever you want with it. Now, so the main takeaway from this is this callback thing. So now everyone understand what is a callback. It's simple like that. Like an event has happened and you want to do something with that event. In this case, the click has happened. You want to do something like that. Let's say in this case, the click can be something else. Let's say I want to trigger this when I hover on the. There is not something I hover. It is called mouse enter. So I take the mouse to here, and the alert pop-up is shown. So the reason is like the event type has changed now. It is mouse enter. Okay. Once the mouse enter event is triggered, I want to call this function. That is what we call as callback. So the same callback applies for set timeout as well. Once the timer has finished running, call this function. There is something called set interval as well. This is also a browser API which takes an interval, and for this particular interval, it keeps on executing. So let's say I want to execute this for each and every 1 second. I believe you have used this for the clock, right? Come on, guys. I'm the only person.
Yes, sir.
Yeah. All right. Okay. So we covered what is a callback. Now, there is something I want to tell you before we move to the concept of promises. So let's say, imagine this situation. So we call it as callback hell or pyramid of doom, because this creates a pyramid structure, right? So the reason is like, look at this function. So you're getting the user data. This is a callback. Once you get the user data, this callback will be triggered and it will give the user object. Now you get the profile picture of the user with the user you got from the previous function. Now with this profile picture, you are updating the profile with the data you got from the user and the picture you got from the get profile picture. And with this update profile, you notify, after this update profile is done, you notify the user with the user data you got from get user data, and you are just saying a notification. So look at this thing. So let's say you have 20 more other things as well. So the callback will keep on growing, right? You understood the problem, or anyone have doubt in this? Like,
Can I explain one more thing?
okay. So the functionality of this is like, let's say you have a API to get a user. Okay. Now you hit the API and you got the user, and this function will give you the user object. So that is how APIs work, right? Now, once you get the user, based on that, you get the user profile picture. So what you can think is like, I can get the user profile picture entirely in one single call, but in this particular place, think like only you can get the user by get user data, and for the profile picture, you need to call another function. So each function is depending on the result of the previous function. Okay, so get user data returns the user, and this get profile picture data depends on this user. So only when the user object is received, you can call this profile picture. Only the profile picture is received, you can call the update profile. Only when you update the profile, you can call the notify user. So this is what the each function is dependent on the previous function. So that you need to call these functions. You have to call this function only when the previous function returns a value. So that happens within this callback. So that caused this callback. This is a problem. Now, to avoid this problem, we are using something called promises. I'll tell you. Maybe before even going to this, I will tell you how we make API calls with JavaScript so that you understand why we need this concept of promises. Okay. So let's take some API like to do JS. There is something called JS type code. Yeah. Yeah. So we copy this piece of code. Even if you don't understand this, it's okay. I will explain you what it is. We will remove all these things. So here the switch function is given by browser, and you are hitting a API here. So this will give you list of to-dos. I will open this in a normal browser. This will give you this to-do item, one to-do item. If I remove this, it will give you list of to-do items. So just a normal API call. You know what is API call, right? You hit an external server from your machine, and that external server will return you some data. In this case, it is returning a JSON. Why JSON? Because JavaScript will understand JSON. You can loop through this and then display it in your browser. Okay. So now, so with this JSON, so what you are saying, you are getting this JSON and then you are console logging it. Let's say, let's run this in browser. I refresh this page. You can see here, right? So the browser has made a API call. You can see it from here. If you go to network tab and select this switch, you can see the browser has made the API call. How did it make the API call? Because we use the switch function. That's why it made the API. So immediately when it made the API call, we are doing something called .then, and then we are taking that response, and then we are extracting the JSON from that response, and then we are console logging that JSON. So So this is what the concept of promise is. But before this, before the invention of promises, or I don't know if fetch has a callback. Okay, I will show you how it will work without the concept of promises. Give me a second. So we will take a XHR example. So XHR is a very basic way of making API calls. Like instead of if in fetch you have directly call the API call, but ideally under the hood the browser executes something like this. Okay, we take this piece of code, copy here, and then we comment this out. Take the same API call, and then we put it here. And then let's try this. The same API call has been made. Okay. Now look at this. So this XML HTTP request is a browser API. Okay, we spoke about the set timeout and everything, right? Something related to that. So the browser takes care of running these things. So we studied about different statuses. So in this case, if the status is 200, what it is? Anyone? What is the 200 status code mean? Everyone did a homework on this. Come on.
Successful.
Success, correct. Okay. So if the status is 200, we are console logging the, let's say, console.log. We get the data here, but let me check. Yes. Yeah. So event is triggered, but we don't get the data here. Okay, this is XML HTTP event. Let me see how to grab the data here. XHTTP.response text. That is how we get the data. Now, if you go back to our app and console log, you get the data. Okay. So I will tell you how this works. You say the browser that I'm going to make a HTTP request. I'm going to make a API call. And this variable, which is written by this XML HTTP request, will give you a bunch of methods. If you click a dot here, it says open, on-ready state change, done, headers received, all those things. You ignore all these things. For now, concentrate on-ready state change. So now match with the callback concept we discussed. What is this? So this whenever this on-ready state change event happens, call this function. Okay, and this is not data. I was wrong there. It is an event. Like button click, I had an event, right? Same, this is an event as well. Okay. Now, inside this callback, I have this. This is within the scope of this function, and it will give all the variables, all the properties that belong to this XML HTTP request. So in this case, the ready state is 4, which means the request has been completed. There are different ready states. If you see this, if you go to Mozilla Development Network, you can see different ready state. So the client has been created, open connection has been opened, headers received, loading. 4 is done, which means the operation is complete. The API call has been completed. So when the API call is done, that is what we are saying here. When the API call is done, and the status is 200. Status should be 200. It should not be a error 500, 400 or something like that. Then console log this. So you understand the concept of callback, right? It is similar everywhere. So event has happened and the function has been called. Okay, so imagine we will come to the concept of callback here. Let's say I'm going to make another API call based on this data. So in this case, const to do equal to this text, which means the API dot. What is that thing? Response text. And based on this response text, I'm going to make another HTTP call here, and I'm going to execute another function. So this keeps on going, right? So ideally what happens is like this function call keeps on adding up instead of having a flat structure. So JavaScript has this concept of promises. I will comment this now. Instead of doing this complex way, JavaScript has this simpler way to do this. Like you call this fetch function and then do a dot then, and then inside the dot then you do your callback stuff. You get a response and you return the response.json. I'll say why we do response.json and then dot then. Again, you will use a callback and then you get the data here. You may call it data, so you can call it whatever you want. Data. So now if I go back to the browser, execute this thing, you will still get the data. So the reason behind why I am using this instead of this is like, one is like you don't need to do all this stuff here. The response itself will have all your status code. If I console log the whole response here, you can see it has the status code 200 and all those stuff. So one more thing is like you are getting a JSON here. It can be a text data as well. You need to explicitly tell the browser like I'm getting a JSON here. So otherwise the connection will be still open because it is connecting to external system. So I need to get the response.json and then it will grab the JSON and then it will return another promise and it you can console log the data. Now I'm talking about the concept of promise here. Now what is a promise? I will tell you exactly what it is. So here. So promise is another web API like your set timeout, your fetch call, which we have discussed now. Okay. So whenever the browser encounters a promise, there are three things that can happen. One is like the initial state, like pending, which is like API call. You make an API call. The API call is in flight. In flight means you are making the API call. It is going and fetching the data. Second is fulfilled. Now the API call is completed. You get a 200. Now there is another thing. API call is rejected. So I'm giving API call as example. It can be anything. You can call a promise. It will be executed asynchronously, and you can decide to make succeed it or reject it, which means in this case they call it resolve and reject. Okay. So yeah. So that is about the promise. So how can I execute a promise? What are the things that returns a promise? For example, if you are returning a number, if you are returning 10 in a function, it returns a number. You are returning a string like John Doe, it returns a string. In this case, similarly, this particular fetch returns a promise. How can I see that? You can see here, right? So this returns a promise. So promises are thenable. Thenable means you make a API call, fetch, and then what happens? So if it succeeds, what happens? If the API call succeeds, it will call the then. If it fails, it will come to this catch block. And then you can display a error. You can console log it, or you can do whatever you want. You can give an alert that says, sorry, API call failed. Okay, now let's fail this API call. Let's call this to do instead of to do's. I think we don't have that endpoint, so that this API call should fail, and we should get a alert ideally. But okay, okay, somehow it got failed, but still I didn't get the alert. Okay, so only 400s are being returned. Let's say, I make the whole URL itself as strong. What happens now? Now you can see. Oh, there is a typo. So it's API call failed. Okay. Now you can see it has hit the catch block. Now, why it has hit the catch block? Let's see the diagram again so that it will be clear for you. So in the pending state, the API call is inflated. It is you have made the API call. It is going and fetching the to-do data. Okay, it is going and fetching the data, trying to fetch the data from the URL, trying to hit the URL. Okay, now if it succeeds, it would have ended up in the dot then block. If it has failed, it would have ended in the dot catch block. Okay, so there are three states. One is pending state. If it succeeds, goes to the then block. If it has failed, it goes to the catch block. Now, forgot about this fetch. Let's say we can create a promise by ourselves. We can do like new promise, and then it takes a function. It takes two parameters, resolve and reject. And then now you can decide to resolve or reject this promise based on something you do. Okay, this will be executed asynchronously for you. So instead of blocking the main thread. So now let's say you should ideally people define a asynchronous operation here, right? So in this case, let's say we do a set timeout. So in this case, after 2 seconds, we will resolve this promise. So what is resolve and reject in this? So ideally, if you see the fetch right, like I said, if it succeeds, it comes inside the then block. If it fails, it comes inside the catch block. How is fetch doing it inside? Internally, fetch uses a promise. So whenever the API call returns a proper 200 status code, it will call the then block. If it is returning 500 or there is an error, it calls the catch block. So in this case, the then is called when fetch calls resolve, and the catch is called when the fetch calls reject. I will explain this clearly for you. So let's say it's the same data. We can think like we can return a JSON here. Greet, hello. Okay, now this promise is thenable. Then we call a callback with the response. You can call it whatever you want, like I said, you just call it RES. Now you put console.log RES. Now, since we call this resolve and reject. So again, internally, if you see, whenever I command click, it is showing me the internal code for you. Okay. Where are promises? Yeah, you can see, right? So this function start here. So there is a resolve method and there is a reject method. Okay, so you're using this resolve and reject. You can name whatever you want. Resolve and reject, RES, REJ, something like that. Okay. Anyways, when you feel it is a success scenario, you call the resolve. When you feel it is a failure scenario, you call the reject. That is how it works. Okay. Now, so since we are considering this is a success scenario, after 2 seconds we are calling the resolve. So which means it will come to the then block since it is a success scenario, and it will be console logged. So I will refresh the page. We wait for 2 seconds. And then we say greet hello. Okay, let's say I'm rejecting it here. Now I want to print this. What should I do? Anyone? Arvind?
Sir,
So I want to print this greet hello now. Will it print?
it's no, sir.
Let's try now. So uncaught and promise. Why is this happening? Why is this uncaught and promise? It's still printed, but why is this uncaught and promise? What are we not? So what is the past tense of what is the present tense of caught? Caught is past tense, right? Come on, guys. I'm just asking a normal English question.
That's
Catch. So what are we missing here? We are not doing.
yes.
Yeah, we are not catching the error because reject will throw error. Like we are explicitly saying throw error. So you can ask me, sir, why are you doing reject greet hello? Because programming languages doesn't know how to do it. Just give you the APIs. Like it will give you for loop, it will give you while loop, it will give you promises, fetches. It's up to you to do whatever you want. So in this case, the promises give you an option like resolve or reject something based on your own scenario. In the previous scenario, we made the API call. So it can easily decide whether the API call fails or not. There are some scenarios where you execute code asynchronously and you will decide yourself that this is a success scenario or this is a failure scenario. At that time, this resolve and reject will come to you in handy. So you yourself can decide, I now decide to reject this. I now decide to resolve this. Something like that. Is it clear? So in this case, you decided to reject it. Okay. So which means it will give a error. So whenever I'm giving a name here, I'm giving whatever I want. Is it confusing for you? Anyone? No clear?
No, sir. No, sir. It's not confusing.
Oh, okay. So I put a error. Now, ideally, we should not see that uncaught error because we have caught that error. That's why we are saying just greet hello. Okay. Still, this failed to fetch is happening because we have changed this. Yeah. API call. The API call succeeded as well as the greet has been printed, but this time it is inside the catch block. We can go inside catch block. Two seconds. Seriously? Oh, I'm doing it in the fetch. Sorry. Refresh it. Inside catch block. Okay. Any doubts in this? Last 5 minutes. Let's continue this tomorrow if I have time. And I want you to like try this by yourself so that it is a very confusing concept. I have covered so many things in this. It is a very, very confusing concept. Okay. So try to wrap your mind around it. Try to create a promise around set timeout, resolve it, reject it. Inside the set timeout, have some logic. And based on the logic, either try to resolve or reject. Try to do multiple then. And because the then is chainable, you can do then. So instead of having it. Now, coming back to the concept of callback hell. Now, why I showed this callback hell is before the concept of promises, people, what they do is like they call a function. So based on the return value, which is this, that let's say this get user data is making API call, it's returning a user, and inside that success callback, they make another API call, and inside that success callback, they make that another API call. Because since JavaScript is asynchronous, you cannot call the function outside this function, because in only inside the success callback you will get the data. You understand that, right? So previously, before the concept of promises, people have to do this. But when the promises came into picture, now you have a flat hierarchy. Let's say you have the same structure here. You will return one promise here, make API call, like you make a API call here. Same way, you keep on doing this, but the hierarchy will be flat in this. So this will return some data here, and this will return some data here. This will return some data here. You keep on doing it. So instead of calling a function inside function inside function inside, so the promise has simplified the stuff. So any doubt on this? Quickly. Come on, folks.
No, sir.
Everything is clear, Akash?
Yes, sir. But can you actually send the document actually which you presented in the screen?
Oh, this whole code.
Not this whole code, but when you present it in the, this one.
I believe I can share this. Export to link. Copy. Let's put it in our Discord group. Okay, let me know if you can open this and see the. Is it accessible? Akash? Everyone?
Problem.
All right then.
Sir.
What's your doubts here? And this is a very important concept. Any API calls you are going to make, because you are not going to display digital clocks or just click the buttons, right? You are going to make API calls, get the data, display it in the UI and all those stuff. So for all those stuff, you need to understand the concept of asynchronicity in JavaScript. What is synchronous? What is asynchronous? What is promise? And how fetch uses promise inside? What is? You don't need to understand that XHR part. It is good to know, but you are not going to use it in real life anywhere. This is a very old even before I started doing JavaScript, people were making API calls using this method. So currently we don't use this particular method. Anyways, internally this is how the browser executes fetch method. Fetch internally calls it. So anyways, they are abstracting all these things and giving you a very nice and easy API for you to consume. Okay. All right then. Post your doubts in the Discord group, and thank you. Bye.
Thanks, sir.
Thank you, sir.